All right, what we're going to do is some more of the factoring. We're going to go through the steps, look for greatest common factors, look for trinomials, look for difference of squares, whatever the case might be. They're all mixed in, so we've just got to determine what it is. There is no greatest common factor on this problem. There's a 2, a 1, and a 3, so all I can do is break this down into 2 sets of parentheses. The only way to get a 2x squared is with a 2x and an x. The only way to get a 3 is with a 3 and a 1. I want to create a negative 1 inside of here, so I have a 3x and a 2x. The only way to create a negative 1 is to have a negative 3 plus a 2. So a minus 3 and a positive 1. My next problem, I have no greatest common factor again. I'm going to try 3x times 2x first. Typically, the ones that are closer together give us the correct answer. Whether or not that's the case in this problem, we'll see. I'm going to try 5 and 2, which are factors of 10. If I put 5 here and 2 here, that gives me a 10x and a 6x. So no, that doesn't work. So I'll have to get out my eraser, try it again. This time I'm going to flip-flop those. 2 times 5, that gives me a 4x and a 15x. I can get 11 if I'm subtracting, which I am. I do need a negative 10, so I need one of them to be a subtraction, one to be positive. So this would have to be the positive because I need a positive 11 minus 4. Minus here, positive there. A few more problems here. Ooh, I noticed in this one there's no greatest common factor, but I noticed this is a number squared, 4x times 4x, and this happens to be a number squared as well. So I'm going to put 4x times 4x, and we're going to try 3 times 3 to see if this works first. This is going to be my first guess. So I've got 12x times 12x, and sure enough that gives me 24. So I'm going to put a positive and a positive, and I'll write this as a quantity squared. This next one says factor completely. That's telling me that there's more than one step. The greatest common factor between these two happens to be a 5. They don't share any variables in common. I'll write 5 times 4x to the 4th is 20x to the 4th minus 5 times 9y squared is 45y squared. Now this is not factored completely because now I have a difference of squares. This and this are both two things that can be multiplied together are the same thing, so they're both squared. 2x squared times 2x squared gives me 4x to the 4th, and 3y times 3y gives me 9y squared. So I'll finish this by copying down my 5 and breaking this up into a difference of squares. 2x squared times 2x squared gives me the 4x to the 4th, and the 3y times the 3y gives me the 9y squared. Minus and a plus gives me that 0 term in the middle and takes away that middle term. This is my final answer. On this next problem, I need to go through my steps and say what is the greatest common factor. There is a number that they all share in common, 3. So I'm left with x squared plus 3 times 21 is 7x, 3 times 18 is 6. And then I can break this up into 2 sets of parentheses. So I need a factors of 6 that give me 7. These are the 2 that are going to give me 7. So I'll put x times x and 1 times 6. And we'll check this to make sure it works, which it does. 6x plus 1x is your 7x. This last problem says factor by grouping just for fun. So we'll give it a shot. What's the greatest common factor here? That would be a. We're left with then a b plus 4 on the inside. Plus the greatest common factor here is a 2, and I'm left with a b plus 4 on the inside. Write this as one term, and then this other part comes on the outside, a plus 2. So my final answer would be a plus 2 times b plus 4.